Hello, my name is Carl Fawcett and I'm with Airfoil Generators. We're developing the next generation of high efficiency wind power, and now we've got a model that's printable. Let's go look. Here is part of the rotor for one of our all-new Model M6 printable wind power generators. In this video, I'm going to show you how we designed the parts to be printed. We'll even watch them being printed, and we'll take a look at how they look and how well they go together or don't at the end. So let's get started. As this image shows, the M6 is designed to be the perfect partner for battery charging and solar augmentation or any other off-grid use you can come up with. But don't be fooled by its small size. The M6 has a peak output exceeding 800 watts and can generate a reliable 100 watts in common 10 to 12 mile an hour winds. Let's take a quick look at the rotor assembly in CAD that we are about to print. As you can see here, the rotor is sectioned into many different pieces so that they're small enough to be able to be printed within many common printers. We happen to be using a Bamboo H2D, and we've learned that in this printer we can print 3 blade sections at a time. Now I've exploded it a little bit so you can see all the parts as they relate to each other. You can see here the locating pins. Those locating pins are pretty important. They keep the edges of the blades tight and aligned with each other so that when this is collapsed, those joints are strong. You can also see the drive shaft that runs up the center. All the blades are attached to it. This makes the design inherently very efficient because there's no energy lost. When the blades turn, the drive shaft turns. When the drive shaft turns, the generator turns. It's just that simple. Now let's go watch those rotors actually being printed. While this prints, let me give you a little information about this job. We used matte black PLA filament with standard PLA bed and nozzle temps and a standard print layering thickness of 20 thousandths per layer. We selected PLA because it's cheap and it's easy to work with. Our goal in this print was simply to confirm that parts of this size could be printed in the space envelope of the printer we're using, and we wanted to see how tight the locking dovetails between the parts were going to be. When we have our CAD files tweaked for the best fitment between the parts, we will print a set of rotor blades in ASA filament for final assembly and testing. ASA is recommended for anything that is going to spend its life outdoors in the weather. It has high UV resistance, great strength, and low water absorption properties. Here's a picture of the 3 finished rotor sections still in our Bamboo H2D printer. An H2S or any other printer with a similar space envelope would also work. Let's have a look at these printed pieces. You can see how they fit together to make a rotor with 5 helical blades and about a 2-foot diameter. This is one row, if you will, of 4 rows where this would be stacked together, one on top of another until the finished rotor for the whole wind generator is 4 foot tall. The process is like this. First, of course, we print them and then we fit them all together to make sure we want to know how well they fit with each other and the drive shaft and the other components. Then adjustments, of course, need to be made, and we go back to the CAD files and sometimes the printer settings to get rid of gaps and tighten up the fitment where we see that we need to. So in summary, the CAD design is complete, the CFD testing is done to confirm all of the outputs, and now we're printing the very first pieces so that we can build a working model, put it outside and test it. If you'd like to follow along with this wind generator development, please click like and subscribe so that you'll be notified every time a new update comes out. Information on all our airfoil generator models, and we do have bigger ones, is available at our website, and that is airfoilgen.com. I hope you'll go and give it a look. As always, we'd like to thank you for your attention. Appreciate your following along, and I look forward to talking with you again soon. Goodbye.